Hello and welcome to today's daily Leetcode challenge. Today we'll be solving question 456 called 132 pattern. I'll be going through my thought process as I come up with the solution, and then stick around for the end of the video where I compare my solution to the solution of others. With that, let's begin the question. And so here I'm given an array of n integers, nums. A 132 pattern, so 3-2 pattern, is a subsequence of three integers. So in the array, a subsequence of some 1, 2, 3 integers, such that I is I is less than j is less than k, and nums I is less than nums k. So nums I, let's draw this as a graph or as a chart. Some I, some j, and some k, such that I is less than k. K and k is less than j. So something like this. Boom, boom. Cool. So we're looking for this 132 pattern in our nums array. And if we find one, return true, otherwise return false. So what's an example of these 132 patterns? Well, 132. So an array with values 1, 3, 2 would be valid. An array of size of elements 1, 4, 3 would be valid, all because they follow this pattern that I is the smallest element, j is the largest element, and k is somewhere in the middle. Okay, cool. I think I understand the question pretty well. Let's look at a couple of examples. So we're given nums 1, 2, 3, 4. This is false. I can't find anything within there that follows that pattern. Let's look at 3, 1, 4, 2. What about 1, 4, 2? 1, 4, and then 2. So this passes. Let's look at another one. Negative 1, 3, 2. Negative 1, 3, 2. Negative 1, 3, and 2 somewhere in the middle. So also passes. Okay, this, yeah. Yep, this is definitely legitimate. I think let's see, what would one kind of approach be? Well, I wanna iterate through, sorry, the simplest approach would be to have three for loops bounded by what I, j, and k could actually be. So for example, I is not going to be the whole range. It's going to be from 0 to length minus 2, not inclusive. And then have those three nested loops. Within that nested loop, we would have like a condition that if basically nums I is smaller than nums k, smaller than nums j, then return true. However, the chances of a array that is of size, and let's look at the size. The size could be of 2 to the power of 5 to the 10 to the fifth. So that's it's going to be O of n cubed, which is there's no way that that's going to be possible, right? So we probably have to do it in one passing, and in one passing, the most like the idea that I get right away is, well, why not, as we're going through the array, we find something like the bottom and the top for each element. And what that would mean is, if we're finding bottom and top for each element, then we are we know at each second or at each new element what are these values here, the bottom and the top. And then if the value that we encounter here is somewhere in between those two, then we would be fine, right? We would be fine. The problem there is that, uh, what if it is a situation like this, 1, 2, and 3? We would still have the bottom. We would still have the, oops, sorry, we would still have the top and the bottom, but they would be in not a correct order, in an incorrect order, right? So we really need to know um, what the order is there. 1, 3, 1, 3, 2. Okay, so this doesn't work. Let me actually just get rid of that so it's not confusing. Um, okay, so what's another approach? Well, what if we're going through the array, but from the back? So I'm gonna draw this array as like a chart. Um, boom, boom, boom. If we're going through the array from the back, we could keep track of the highest element, high, and previous high. And if we do that, then and set the high and the previous high to some initial values, then if we encounter an element somewhere down the line that is less than, the um, previous high, then we could essentially say that we found this element um, that is less than high and previous high. And the reason why we know that this high would be further down the line from the right than the prev high is because prev high is only set when when a new high is found, right? So I think that should be the way that we go about it. Let's start implementing. Let's have high is just equal to nums minus 1. Prev high is equal to some insanely large value. Um, what was it? 9, I think was the top, right? Oh, 5. This is also possible. Okay, and now we say that for n in reversed nums, I want to say, if n is less than prev high, then return true. And if we find a new high, so if n is larger than high, then I want to say prev high is equal to n, and high is equal to, high is equal to n. And that's it. Return false if we don't ever find this condition. Cool. Let's see if that works. Awesome. Oh no, we have an error. Let's test use case. Okay, so what is happening here? 1, 3, 2, 4, 5, 6, 7, 8, 9, 10. Huh. Okay, so actually, what's happening here is probably that there is a high and a prev high, but if I draw out one, let me actually just, yeah, let me remove all of this here and draw out what a 1, 3, 2, 5, 6, 7, 8, 9 would look like. It would look something like 1, 3, 2, 4, 5, 6, 7, 8, 9, 10. Boom, 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 boom. Okay, so we have high set at this element. Um, oops. Prev high is just in some insane number. Uh, and so we're moving. Oops. We're moving uh, one by one, and we still don't find anything. And then at some point, we encounter a situation where we do have this fluctuation, right? Um, we do have this essentially number being greater than the number here. So, you know what we could do? We could memorize what the values of high are so that we could essentially set prev high to the value that we need, which is actually this one, in the case where there's a value that basically overrides one of these like previous highs, because initially this is almost like none. This is none. This is not set at all. So, okay, the way that we could do that is have a stack. We could have a stack keeping track of all the elements uh, from lowest to highest. So in this case, highest would be on the bottom, second of the bottom, third, fourth, fifth, sixth, seventh, then eighth. Then this. We would have to pop this eighth element in order to remove it for the ninth. But when we do that, eighth would be going to previous high. And so actually, let's just look at what the elements would be in the stack and how the stack would look like um, throughout this journey. So first it would just be 10, then it would be 9, 10, 8, 9, 10, 7, 8, 9, 10, 6, 7, 8, 9, 10, 5, 6, 7, 8, 9, 10, 4, 5, 6, 7, 8, 9, 10. All of this time, prev is still set to none. Then I have not 3, 4, but I have 2, 2, 4, 5, 6, 7, 8, 9, 10. And all of a sudden, I encounter a new value, 3, that basically beats this 2, right? So initially this was 2, but I would replace 2 with a 3, 4, 5, 6, 7, 8, 9, 10. And only at this point, prev, I just realized you guys didn't see this. Only at this point, um, previous high would be now set um, to 2. And then when we encounter this last element, we found the 3, the 1, 3, 1, 3, 2 pattern. Okay, let's make that modification real quick. So instead of high, we have a high stack, which is just equal to an array. We still do this reverse. We still do previous high. Let's say while high stack and high stack -1 is less than n, we're simply going to say previous high is equal to high stack pop, and yeah, let's append n. So let's see if this modification takes care of that test case. It does. We've done exactly that. We've kept the stack consistently increasing, and when we pop something, is only then do we essentially say that we've populated this previous high. And okay, let's see if that works. Should work. Awesome. So this is an ON solution. Let's see, are there any other? No, this is identical actually. So yeah, there are no other solutions for this. And yeah, this is a very clean approach. I understand that it's hard to see, but maybe this iteration of thought helped you guys. Um, okay, well, with that, let's end it for today. Thanks for watching. See you later. Bye.